Okay, so on Friday we did the partial fraction decomposition. The first step is to factor the denominator. So how do I factor x squared minus 2x minus 8? Good, minus 4 plus 2. And the order there doesn't matter as long as in the end we have the right numerator with the right denominator. So then this becomes a over x minus 4 plus b over x plus 2. So the a is missing the x plus 2 and the b is missing the x minus 4. So now I grab only the numerators and I get 3x minus 1 equals a times x plus 2 plus b times x minus 4. And then I can either do it from here or from where we're at to determine what are the two numbers I have to plug in. But at one at a time, I'm going to plug in positive 4 and then negative 2. So if x equals 4 here, and then x equals negative 2, I would get 3 times 4 minus 1 equals a times 4 plus 2. Plus, this is going to cancel anyway, so I can skip it, but I'm just going to show you for today. That would be 12 minus 1, a times 6. This is 0, b's gone. 11 equals a times 6. Divide both sides by 6. And a is 11/6. With me so far? Then b, I'm going to plug in negative 2. So 3 times negative 2 minus 1 equals a. This one's going to cancel, so I don't have to write it. b negative 2 minus 4. And I get negative 6 minus 1 equals, this is gone, b negative 6, negative 7 equals b negative 6. b is 7/6. So now the a has to go over the x minus 4 and the b has to go over the x plus 2. I would get 11 over 6 over x minus 4 plus 7 over 6 over x plus 2. But remember, we can't leave the fraction within the fraction. So we bring the denominator down, and it would be 11 over 6 parentheses x minus 4, and you want to keep it that way. You don't want to distribute. 7 over 6 x plus 2. So this is one way your answer can be written. The other is if they have the same denominator there, I can actually pull out a 1/6 and get 11 over x minus 4 plus 7 over x plus 2. So if this was multiple choice, honestly, I haven't gotten to your test yet, but let's say this part of your test is multiple choice, it will be written like in the pink. It will pull out that common denominator. But for your quiz, you're going to write this answer on your answer sheet. I would take either of those. Either of those is fine, okay? And remember, the order is not important, right? So like if you had put the x, so like when Taylor gave it to us as x minus 4, x plus 2, if you had done x plus 2 and x minus 4, it's fine. The order would be switched, but the 11 has to be over the x minus 4 and the 7 has to be over the x plus 2. So when I go to like check your work, that's what I'm looking for. The right numerator with the right denominator, not necessarily in that order, okay?
Like, how do you know that the 11 goes with the...
If you had switched the denominators, then a would have been 7 over 6 and b would have been 11 over 6. So when you go plug it back in, you'll figure it out because you'll say, oh, that one goes over that one and that one goes over this one.
Oh, okay.
Yeah, you don't need to like figure that out. Does that make sense? Yeah, it will work out that way.
Okay.
Yeah. It's more for me when I'm checking it, like I'm not checking the order, I'm checking to see does the 11 go over the x minus 4, does the 6 go over, and then the order's okay.
Just to make sure I don't put the 7 over 6 over the x minus 4.
Correct.
Okay.
Yep. Come back here, and from this equation, I could distribute the a, distribute the b, and then group together the x's. And then group together the ones that don't have x. These cancel, right? And I get 3 equals a plus b. And negative 1 equals 2a minus 4b. And then I have a system to solve. So that's why this section is in this chapter. Because you can use systems of equations to solve it. I just think the other way is easier.
So then can you do the other way?
No.
That one on?
No. Because you can't. All right, then the last one was your repeated factors. So the first thing I have to do is factor the second trinomial here. This is x, and then this is x minus 1 times x minus 1. which is my repeated factor. So when I rewrite these denominators out, I get a over x, b over x minus 1, and then this would be c over x minus 1 squared. So remember, you have to build up to how many terms there are. There's 2 of the exact same ones, so that's why it's got to go from the first to squared. Then we multiply out what's missing. So the a is missing both the x plus 1s and the x minus 1s. The b is missing the x and the x plus 1. And the c is just missing the x.
So this first one, so why for a, you don't put x cubed, x plus 1 cubed? Because don't you have 3?
But you have just x to the first, so that's not a repeated factor. Is that what you mean? You mean what you're multiplying in the denominator?
No, like yeah. So like, when you multiply like on top x minus 1.
No, the x is already there, so I don't need that
No,
one.
not x.
Oh.
The-
Oh, this should be minus 1 and minus 1. Hang on. That's not what you're saying, though, right?
that. So if you were multiplying all 3 of those numbers to a, wouldn't it be x minus 1 cubed, not squared?
So you're only multiplying by what's missing from the denominator. So when I look at this, I'm comparing this to this. I have the x, I'm missing the x minus 1s. Does that make sense? And then go B, look at this to that. I'm missing the x and the x minus 1. And then C, you're only missing the x. So now I'm, sorry, go ahead.
X minus 1 squared.
Because it's a repeated factor. Remember that like last week I tried to like hone in like the y, and then I just said at the end, just it's one of those, it's because I told you so?
Yeah.
Yeah. As an adult, we say that sometimes and it sucks, but it takes less time than to explain it to you. It's because if you don't, Matt, you'll never get back the original denominator. Like if I made it x and then x minus 1 and then x minus 1, my least common denominator is going to be x and x minus 1, but that doesn't match my original denominator. The only way to get it right is to build it up.
Right.
All right, so now I'm going to set my numerators equal to each other. So 2x squared plus 3x minus 1 equals, this I can FOIL out, and I would get x squared, it's this, right, what we factored over here, minus 2x plus 1, and then distribute the a to all of it. So I get a x squared minus 2ax plus a. Then I go to b, bx times x would be bx squared minus bx. And then c is just cx. So now we group together everything that has an x squared. So has an x squared, has an x squared, has an x squared. 2x squared equals ax squared plus bx squared. Then we group together everything that has an x. 3x equals negative 2ax minus bx plus cx. And then we group together everything, do a different color, that doesn't, ooh, that's not what I meant to do. Hey, undo. That doesn't have an x or an x squared. Negative 1 equals a. So we can come back through and cancel out all the x squareds here, because if I divided everything by x squared, they would cancel out. I can do the same thing with the x's here. And then that last one is already solved for the variable. So this is actually a triangle system. I've got an equation with 1, an equation with 2, and an equation with 3. If I wrote them on top of each other, it would look like the original ones, okay? But this one's already solved, so then I have to take that and plug it back into the other one. If I plug it back into the second one, there's still 2 unknowns. So I got to plug it back into this first one. 2 equals negative 1 plus b, so b equals 3. And now I've got a going in here, and b going in here. And now I've got a, b, and c that I'm going to plug into my original fraction up here. A is negative 1, so minus 1 over x. B is 3, and C is 4. So I said it Friday, but I'll say it again. I didn't put the repeated factor questions on your quiz. I don't know that I won't put them on the test, but I haven't made that yet. So just keep in mind that this is something you want to know how to do, but I did not put it on the quiz for tomorrow.
So then you do grouping only for when you have the double one? Or
You could actually do, like if you look at here and I say, this has to equal 0, this has to equal 0, this has to equal 0. What I'm plugging in is 0, 1, and 1 again. 1 is going to always, 0 is always going to cancel out C and B, so I'd solve for A. But then 1 is going to cancel out A and B, I'd solve for C. I'd never be able to solve for B. Does that make sense? You can't do a repeated number twice. It'll never cancel out the third variable. You always cancel out the same two. The homework question came up, this one, the same thing, write the partial fraction decomposition, express it. So this should be x plus 4 and x plus 5. And then, did you put a over x plus 4 or a over x plus 5?
I'm opening it in 3 seconds.
Okay.
Was it the a over, I did x, a was x plus 4.
Plus 4?
Mm-hmm.
Okay, so then this gets the x plus 5, x plus 4. X minus 2 equals a, x plus 5, b, x plus 4. And you plug in a negative 4 and a negative 5. God bless you. This one's gone. Nope, other way around. Would help if I divide correctly today. Negative 6. And then this one, negative 5. This would cancel. Positive 7. So then this goes over the a, so negative 6 over x plus 4 plus 7 over x plus 5. You put the same thing for a and b.
No, I just noticed that I subtracted minus 1.
Negative, okay, I got you, instead of dividing. Okay, so this is your right question. So the first thing you want to do is factor this, right? So x plus 2, x plus 7. Did you give a the x plus 7? Then this is missing the minus, and this one's missing the plus. To figure out, so it's 1 equals a, 9x minus 2 plus b, 9x plus 2. Then to figure out what's missing, I'm going to come here and set these equal to 0, and I'd get x equals negative 2/9 and x equals positive 2/9. So that's what you're going to plug in. So 1, 9, negative 2/9, and plus b. So this is negative 2 minus 2, 1 equals a times negative 4. This would be negative 2 plus 2, that one's the one that cancels. And that's negative 1/4. And then the b, well, I know the a is going to cancel out, so I'm going to go straight to b. b, 9, negative, positive 2/9 plus 2 cancels. 1 equals b times 4. And b is 1/4. So this goes over the plus, this goes over the minus, but you don't want to leave them in the numerator. And then they just switch the order, but it's still the same thing. As long as the negative goes with the plus on the bottom and the positive goes with the minus on the bottom. You're welcome. Okay, so when you factor this, it's 9x plus 8 and 9x minus 8. So I get a over 9x plus 8, b 9x minus 8. And then this is going to get multiplied by 9x minus 8, and this 9x plus 8. So I get 1 equals a 9x minus 8 plus b 9x plus 8. So I'd have to figure out what to plug in by either setting these equal to 0 or trying to figure out what's going to cancel those out, same concept. But it's negative 8/9 and then positive 8/9. So if I plug that in, from here, I get 1 equals a times negative 8 minus 8, negative 16, plus this is going to cancel, and then, oh, this should be negative, sorry. That should be negative, and then this becomes 0, so that one's gone. So a equals negative 1/16. Then repeat it again, but this time plugging in a positive 9/8. Positive 8/9. This time this one's going to cancel. And b is 1/16. So then when I plug them back in, a negative 1/16 over 9x plus 8 plus b 1/16 over 9x minus 8. The fractions have to get brought down to the bottom. Yeah. So it should be negative, and then it should be 16 9x plus 8 plus 1 over 16 9x minus 8. Yeah. If you put in the numerator? Yeah, WebAssign would take it. I don't want it. I don't want you to leave a complex fraction inside the fraction. Yeah. Yep. And you can pull out the 1/16, you don't have to, but if this was multiple choice, it would even take it a step further and do 1/16 on the outside. Negative 1 over 9, like that, plus 1 over 9. Like a multiple choice answer is even going to be like that. Yeah. All right, first thing and probably most important is our schedule is different tomorrow. Okay, we have math in the morning for sophomores. So by the time you get to me, the schedule should be like righted itself if anything does get wonky. But that means you need to be on camera at 12:55. This gives us literally 45 minutes, and I'd like to give you 40 for your quiz. That means there's not a lot of wiggle room. So those of you that either run in right at the bell, if you're physically here, or you get onto Zoom after the bell, tomorrow's not that day. Tomorrow's the day to make sure you're on time, if not early. Okay, folks from home, you need to already have your second device up and going. You need to have a scientific calculator ready to go. You need to have your hard copy scrap paper and answer sheet printed and ready to go at 12:55. If anything changes with math, I'll let you know what's happening. But what I would like to do is give you the 40 minutes, and then I have to give you like the 3-minute upload time, which really means we have like 2-minute wiggle room / attendance. So don't mess around tomorrow. Okay, make sure that you're ready to go. So on tomorrow's quiz, there are 8 questions, okay, and I'll talk a little bit about the point breakdown. If you are from home, you're going to print the answer sheet, which is on the quiz review assignment, or take a white piece of paper and model it after it. The biggest things are the first question has a graph, okay, and then there's ample amount of room for that last question because that's the 3x3 equation one. The other thing is I'm not messing around when it comes to work this time. So you can give me the complete right answer and you show me no work and you're going to see all those magical points magically disappear, okay? If you can get to the answer by doing things in your head, you should not be in this class. You should be in a very special class, okay? So if you can answer a 3-system equation with no work, wow, okay? So that, just be prepared that I'm going to be really picky about work. Don't skip your steps. I know what you think. I'm smart. I can skip this one because I'm lazy, but I'm smart. And then you miss a negative or a number in between, and you screw yourself. Not doing that tomorrow. Okay, you're going to write out all of the work, especially when it comes to the systems. So the first system is graphing. This could be 2 lines. It could be a line and parabola. We did examples of both of those. Okay, remember there's special cases there. If they're parallel, they don't intersect, that's no solution. If they're the same line, it's all real numbers. Then, so there's one of those. Then you get one straight up system, which could have fractions or decimals, that you can use either substitution, elimination, that's your choice. And then there's 4 word problems. One, and I say word problems because they have words in them, so you'll see a word and you'll freak out. But 2 of them are ones that we have practiced over and over again, the break even and the equilibrium. Remember, the break even is the one where you get the cost and the revenue and you set them equal to each other. You solve, and those are the ones that you have to round up. So you're going to always round up the units on the break even. And that question will only ask for the number of units that you need to sell in order to break even. Then you've got your equilibrium one. That's going to be a number of units and a price per unit. So that has 2 parts. You're going to solve for X, and then you're going to take it, you're going to plug it back in, and you're going to solve for P. Those have to be whole numbers, okay? Those that you don't round. And then you're going to get like a mix of word problems. We've done perimeter ones. We've done interest problems. We've done ticket sales. We've done a bunch of different things, and you could see a bunch of different word problems from there. It will tell you to set up the system, and then it will tell you to solve it. Then comes, and this is the big one, this one's 20 points. This is your systems of equation with 3 variables. The only way you lose 20 points is by leaving that blank. If you can at least give me something, even if you make a mistake along the way, I'm not going to dock you all the points, okay? So remember, you want to get to your new 1, you want to get to your new 2, and then take those 2 together, eliminate that second variable, and work your way back up.
We're not going to get along where it's just like you give us like Z, and then you just...
No. It's part of that process, but no, there's not enough time. And then you've got the partial fractions where, again, no repeated factor, there's just one of those. So 1 partial fraction, 1 system with 3 variables, 1 system with graphing, 1 system with substitution or elimination, and then the other 4 are word problems. 1 is break even, 1's equilibrium, and then the other 2 are a mix of stuff. You can use scientific calculators only. You may not use a graphing calculator. You don't need it. You could do it without it, but I wouldn't want to have to divide something like 2,760 by 4, okay? It's not going to be fun. So my advice is to have it. I will give you the one on lockdown if you need it. So if you're physically here and you want to use lockdown to have the calculator, you can, okay? Or you can bring your own scientific calculator. From home, same thing. You can either use your own scientific calculator or you can use the one that's on lockdown. But no graphing. Yeah.
Are we gonna have any questions that just straight up ask us to solve, like if it's, or whether or not we want to choose elimination or substitution?
Yeah, there's one like that.
Got it.
Yeah. Posted for your quiz review. The word problem, on the graphing problems, realize that you could get lines. You could get lines and parabolas. I won't go further than that, but we did do some with lines and parabolas. You could get the no solution where they don't intersect, so like parallel lines. You could get all real numbers, and I put ARS for all real numbers. No, ARN for all real numbers. Okay, and this is if they are the same graph, where they overlap in its entirety. And same for up here. Okay. If it's no solution, I write NS, and if it's all real numbers, it's ARN for all real numbers. And that happens if they cancel out and it's a false statement, it's no solution. If they cancel out and it's a true statement, it's all real numbers. So the quiz will tell you that if you're taking it at home. It will tell you what to put in there, but just keep that in mind.
Could you go over a parabola?
A parabola one? Yes. So if you had one that had an equation like this and this, right, you've got a line and you've got a parabola. The line is what I graphed. So 2x plus 1, or 2x plus 1 means that your y-intercept is at 1, and then you go up 2 to the right 1, up 2 to the right 1, up to the right 1, however many times you need, down 2, left 1, whatever it is, however many times you need. Then I would have to graph the parabola. So what I know about this because of the transformations is that this is a typical parabola that points up, but it's shifted down 2 places. And what that does is help me at least narrow down the general shape, but in order to get the points, I need to figure out exact points. So normally we go up 1 and to the left 1, and there's a coordinate point there. But if I want to be sure, holy moly. If I want to be sure, I'm going to plug in -1. So I get negative 1 squared minus 2, and I get 1 minus 2, which is negative 1. And that blue line does have a coordinate point at negative 1, negative 1. So I know that that's an answer. Then there has to be another part that comes up here. I need to find that exact point. I know I'm going to go up 1 and over 1, so that's not going to be 1. But maybe it's 2. If I plug in 2, I get 4 minus 2 is 2. 2, 2 is not on my blue line. So then I go to the next one, 3. And I get 3, 7. And that is on the blue line. So that's my second solution. So there was a parabola question in the homework. There was a parabola question in the notes for 7-1 if you want to look back on those. Okay, and then there's 2 examples on your quiz review of the lines. I did not fraction, like I'm not going to put a fraction on your graphing one because I need you to find an exact point. It doesn't mean there's no fractions in like the systems. It just means for that at least. Everybody else good?
So would you recommend?
So again, the words break even just mean find x, but round up. So we set the cost equal to the revenue, and on the quiz, I gave you the cost and the revenue. This one, it challenges you to like just find the cost revenue equations. And then the equilibrium point has 2 parts to its answer. You have to do x to find out the number of units, and then you have to plug it back in to get p to figure out the price per unit. If you're a Zoomer and you're taking this at home, you do not need to write in dollar signs. You do not need to write down units, like if it was inches or centimeters. You don't need to do any of that, okay? And on questions like that, you'll see it says x equals to the NP equals, hoping that you remember that you need both, okay? And then you've got your system of equation, which really is just this. This is just to help you review the back substitution. Your systems of equation, 3 variables, 3 equation, and again, you're going to show me every step, okay? Do not skip those steps. 1, that's when people make silly mistakes. 2, I'm going to be really nitpicky about your work this time, and I'll take the points off if it's not all there. Actions on the quiz review assignment say to stop at 16. Those are your repeated factors. So you can just do, 14, 15, and 16. Those are your non-partial fractions. So you'll get one of those. Questions for me on expectations for your quiz? All right, you guys.